All right, so today's lesson is going to be about combinatorics and the binomial theorem. We're not going to do a whole lot with this section. This is kind of just a shortcut section for a few problems that we're going to encounter. Really, the binomial theorem applies more to probability, which we will get to in the next chapter. So this is kind of a preview of that, but I just wanted to show you a few problems that you can do with this. So to review, Pascal's triangle. Pascal's triangle is the one that starts with a bunch of ones here, and then you add the two numbers directly above it. So the third row would be 1, 2, 1. I guess the second row, this is the 0 row, first row, second row. And then you do 1, 3, 3, 1. Okay, 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1, and so on and so forth, remembering that each one is the sum of the two digits directly above it. We use that with binomials. If we wanted to expand the binomial a plus b to the fourth, you can't just distribute the 4 and say a to the fourth plus b to the fourth, because that's wrong. Okay, it doesn't work like that. It's a plus b times itself 4 times. You'd have to FOIL that, or you could use the binomial theorem with Pascal's triangle. So we'd actually go to the fourth line here. This shows us the coefficients for each of those terms. So you have a 1, a 4, a 6, a 4, and a 1. And then your first term gets raised to the fourth power, and it works its way down. So then it becomes to the third power, to the second power, to the first power, and to the 0 power. And then your second term starts the other way. It starts at the bottom and works its way up. So you'd have b to the 0, b to the first, b to the second, b to the third, and b to the fourth. Everything's positive here, so you just have plus signs in between. So then just to simplify it, anything to the 0 power is just a 1. So you have 1 times a to the fourth, which is just a to the fourth, plus 4a cubed b, plus 6a squared b squared, plus 4ab cubed. And then again, a to the 0 is just 1, so 1 times b to the fourth is just b to the fourth. Okay, so we do that. Again, you'll see more of this with the probability section, but you're going to see it a little bit with these types of problems as well. I really wanted to show you Pascal's triangle again, because that's kind of where this comes from, more so than the expansion of binomials. But like looking at these two problems here, we've solved these before, but just not in the formal way. So our first example, you want to find out the total number of pizzas you can choose from if you have the following topping choices: pepperoni, sausage, peppers, onions, black olives, and mushrooms. Okay, so those are the choices you have. You don't have to have all of them. Okay, there's 1, 2, 3, 4, 5, and 6 options. Okay, and order doesn't matter, so these are technically combinations. It doesn't matter whether the pepperoni or the sausage goes on your pizza first. Okay, it's still the same pepperoni and sausage pizza, whatever. So if you think about it, you have 6C0. You have 6 options to choose from. Order doesn't matter, and you choose 0. That's a possibility here. But you also have possibilities where you choose one of those 6 toppings. Okay, if you just want mushroom pizza, knock yourself out. You have 6 options to choose from. You can choose 2 of them. You can choose 3 of them, 4 of them, 5 of them, or you can choose all 6. And the reason why I showed you Pascal's triangle to begin with is because of what you're about to see here. So if you do 6 combination 0, there's only one way that occurs. There's only one pizza that you can choose from that has 0 of these toppings. Cheese. It's the only option. Okay, if you do 6C1, there are 6 options that have 1 topping. If you think about it, you have just pepperoni, just sausage, just peppers, just onions, just black olives, and just mushrooms. There's 6 options there. It gets a little bit more complicated when you have 2 options, okay? But you have 15 options to choose from there. Okay, if you continue this process, you have 20 options where you have 3 of them, and then you have 15 options where you have 4 of them. There's only 6 options if you choose 5 of the 6. And again, if you think about it, how many pizzas can you order with all 6 of those toppings? Well, there's just 1. So you see all of these up. What you'd actually be doing is adding them all together. All right, but where do we see these numbers? Well, we didn't get there before, but if we look at the next line in the binomial, or in Pascal's triangle, 1, 6, 15, 20, 15, 6, and 1. Gasp, it's the same thing, okay? So anytime you have a problem like this, just use Pascal's triangle. That's what I was trying to get at here. Okay, and then you can just add them all up. All right. So what's it? 722, 42, and then another 22. So 64 options. Okay. Same thing if you have omelets. Okay, so technically omelets have fillings. Doesn't matter the order in which you put the fillings in there. Cheese, ham, onions, peppers. There's 4 filling options. So rather than having to write out all of these, just go to Pascal's triangle. Okay, find the one with 4. So you have 1, 4, 6, 4, and 1. Okay, so when you add those up, you get a whopping 16 different omelet choices that you can choose. Okay, so just use Pascal's triangle. If you have a question like this, figure out how many options there are, and then go to that line on the triangle.